Welcome to Night Drift Stories. Today, we're diving into 100 incredible facts about asteroids, comets, and extinction events. From icy wanderers streaking across the sky to space rocks that shaped life on Earth, get ready for a journey through cosmic history. Stay tuned, because every fact is a story written in the stars. Chapter 1. Asteroids are cosmic time capsules. Some are older than Earth itself, carrying clues about the solar system's formation. One tiny rock can tell us what gases swirled billions of years ago. Imagine holding history in your hand, forged before life even existed. These rocky wanderers might seem harmless now, but their trajectories shape planets, moons, and even the fate of life. Every asteroid has a story, waiting to crash or pass by quietly. Chapter 2. Comets are frozen storytellers made of ice, dust, and organic molecules. When they approach the sun, they release gas, forming spectacular tails visible from Earth. Ancient humans saw them as omens, but science reveals chemistry that could hint at how life's building blocks traveled across space. Each streaking comet is a fleeting reminder. The universe constantly rewrites the history books in fire and ice. Chapter 3. The Chicxulub impact changed life forever. 66 million years ago, an asteroid struck Earth near modern-day Mexico, triggering fires, tsunamis, and climate chaos. Dinosaurs vanished, leaving room for mammals to thrive. Geologists can still find the crater, and tiny mineral grains tell the story. One rock from space can rewrite evolution. Sometimes, extinction isn't gradual. It's a cosmic punchline with a dramatic twist. Chapter 2. Comets are frozen storytellers made of ice, dust, and organic molecules. When they approach the sun, they release gas, forming spectacular tails visible from Earth. Ancient humans saw them as omens, but science reveals chemistry that could hint at how life's building blocks traveled across space. Each streaking comet is a fleeting reminder. The universe constantly rewrites the history books in fire and ice. Chapter 3. The Chicxulub impact changed life forever. 66 million years ago, an asteroid struck Earth near modern-day Mexico, triggering fires, tsunamis, and climate chaos. Dinosaurs vanished, leaving room for mammals to thrive. Geologists can still find the crater, and tiny mineral grains tell the story. One rock from space can rewrite evolution. Sometimes, extinction isn't gradual. It's a cosmic punchline with a dramatic twist. Chapter 6. Comet nuclei are surprisingly dark. Despite ice being bright, dust layers absorb sunlight, making them nearly invisible until heated. Scientists call them dirty snowballs, but they're more like cosmic stealth bombs. Each nucleus hides secrets about water delivery to Earth and the chemistry of the early solar system. Look up at the night sky, and a ghostly traveler might pass unnoticed, carrying ancient secrets. Chapter 7. Some asteroids spin at insane speeds. Centrifugal force can tear them apart, scattering fragments into space. One asteroid's spin might seem trivial, yet it shows physics in action on a massive scale. Understanding their rotation helps predict impacts and mining potential. Space rocks teach lessons about energy, motion, and danger, all spinning silently, waiting for a curious observer to notice. Chapter 8. Comets sometimes collide with planets. Jupiter, the solar system's protector, has taken many hits, saving Earth from potential disasters. In 1994, fragments of comet Shoemaker-Levy 9 slammed into Jupiter, lighting its atmosphere on fire. The universe occasionally stages grand experiments, reminding us how delicate life's existence is. Jupiter's scars are cosmic reminders. Collisions happen, and survival is a calculated miracle. Chapter 9. Extinction events aren't just dramatic, they're predictable in patterns. Mass die-offs coincide with volcanic activity, asteroid strikes, and climate shifts. The fossil record reads like a thriller, with suspense and sudden twists. Life adapts, rebounds, and sometimes disappears entirely. The Earth's history shows resilience and fragility in the same chapters. Each extinction is a reminder. Survival is never guaranteed, but evolution always writes the next scene. Chapter 10. Some asteroids contain precious metals, platinum, gold, and rare elements more valuable than gold per kilogram. Mining them is no longer science fiction. Companies imagine fleets traveling to these floating vaults. But beyond profit, they reveal chemistry from the solar system's birth. Every metal atom tells a story older than human civilization. Space is full of hidden treasures, waiting for the right explorer and a little bit of daring science. Chapter 11. Some asteroids have moons. Tiny companions orbit rocky giants silently, like cosmic satellites. These mini-systems help scientists measure mass and density, revealing internal structure. Observing their dance shows gravity at work on a miniature scale. Even in the emptiness of space, relationships exist, silent, precise, and surprisingly complex. Asteroid moons remind us that the universe thrives on partnerships, not chaos. Chapter 12. Comet tails point away from the sun, not always trailing behind. Solar wind pushes gas and dust outward, creating long, glowing streams. Each tail is a live experiment in physics, visible for millions of kilometers. Ancient stargazers saw omens. Today, we see plasma and particles dancing. It's a natural light show, powered by invisible forces, teaching the universe's laws without a single word. Chapter 13. Near-Earth asteroids pass closer than the Moon. Some zoom past at tens of thousands of kilometers per hour. Scientists track them obsessively. Even a small miscalculation could spell disaster. The thrill is real. Earth floats in a cosmic shooting gallery. Every near miss is a reminder that life is lucky, brief, and constantly tested by the silent wanderers of space. Chapter 14. Long-period comets arrive from the Oort cloud. A frozen shell at the edge of the solar system. Some visit Earth only once every millions of years. Their appearance is rare, dramatic, and unpredictable. Ancient civilizations witnessed them as signs of change. Today, astronomers study them to understand the solar system's outer frontier. A single icy traveler carries secrets from the very edge of our cosmic neighborhood. Chapter 15. Asteroid impacts release energy equivalent to millions of nuclear bombs. Even a small rock can trigger shockwaves, fires, and tsunamis. Geology preserves these events in shocked minerals and craters. Humanity might survive most impacts, but the Earth itself feels each strike. Impacts are nature's punctuation marks, sudden, brutal, and impossible to ignore. Every crater tells a story of explosive cosmic intervention. Chapter 16. Comets carry organic molecules, carbon, hydrogen, nitrogen, and oxygen, essential for life. Some scientists theorize these travelers delivered the ingredients for life on early Earth. Each streak across the sky could be a cosmic courier delivering seeds of biology. The universe isn't just empty, it's experimenting with life in ways subtle, quiet, and utterly profound. Chapter 17. Some asteroids are porous rubble piles, loosely held together by gravity. Hit them too hard and they crumble, scattering fragments across space. Studying them teaches how structures hold under stress. These cosmic jigsaw puzzles reveal the fragility and resilience of matter in zero gravity. Even destruction has patterns, and scientists read them like an open book written in rock and dust. Chapter 18. Comets sometimes break apart. Internal pressure. Solar heating or tidal forces can fragment them into multiple pieces. Each fragment continues on its orbit, creating temporary meteor showers. What seems destructive is also spectacular, a lesson in transformation and impermanence. The universe shows beauty even in breakup, proving endings can be mesmerizing. Chapter 19. Asteroids often have unique colors. Red, gray, black, even metallic shine reveals composition. Iron, nickel, carbon, silicates. Scientists use telescopes to decode these visual clues. Color becomes a cosmic fingerprint, allowing us to trace origin, age, and history. Every shade is a story of formation, collisions, and cosmic weathering. Space is a palette, painting in minerals and light. Chapter 20. Comet orbits can be chaotic. Gravitational nudges from planets bend paths unpredictably. A comet on a stable orbit today could strike Earth millions of years later. Predicting them is a high-stakes puzzle. The universe is patient yet unpredictable, reminding us that certainty is rare. Even frozen ice balls follow rules laced with suspense, a cosmic reminder that chaos exists within order. Chapter 21. Some asteroids are binary, two similar-sized rocks orbiting each other. Their gravitational dance is delicate, influenced by spin, shape, and distance. Observing them helps scientists understand how larger planets might form from smaller bodies. Even in isolation, asteroids demonstrate cooperation, showing that motion, balance, and timing govern survival in the void. Chapter 22. Comets contain crystalline ice formed deep inside the solar system. Heating near the sun releases gases, creating the glowing coma and tail. This process is a natural laboratory for chemistry, showing how molecules respond to light, heat, and radiation. Each visible comet is a miniature experiment streaking across the sky, bridging the gap between physics and awe. Chapter 23. Asteroids can carry water. Small rocks from the asteroid belt may have delivered ice to Earth, seeding oceans and rivers. Understanding this distribution helps scientists trace the origin of Earth's water. Even tiny rocks can have life-altering impact, proving that size doesn't determine importance in cosmic history. Chapter 24. Some comets orbit planets instead of the Sun. Captured by gravity, they become temporary moons, tracing strange, looping paths. These captured travelers reveal how chaotic and interconnected planetary systems are. Space is full of wanderers, sometimes settling, sometimes escaping, a reminder that stability is temporary and rare. Chapter 25. Asteroids collide with each other constantly. Small impacts chip surfaces, while larger ones can shatter them completely. This slow process creates debris and dust in space, feeding meteor showers and rings. Collisions aren't just destructive, they recycle matter, shaping solar systems over billions of years. Each scar on a rock is a timestamp of cosmic violence. Chapter 26. Comets can outshine stars when near the sun. Their coma reflects sunlight while gas fluoresces under solar radiation. Ancient humans feared these sun glows, but science explains the physics behind the spectacle. Each comet is a transient lighthouse, guiding scientists to clues about the universe's icy outskirts. Chapter 27. Some asteroids orbit close to Earth, called near-Earth objects. Monitoring them is crucial for planetary defense. Tiny shifts in orbit could turn a harmless rock into a threat. Each observation is a small insurance policy, blending astronomy, physics, and strategy, ensuring survival against unpredictable cosmic bullets. Chapter 28. Comets contain dust from the early solar system. Each grain is older than any rock on Earth. By studying it, scientists learn about star formation, chemical evolution, and planetary beginnings. A comet passing overhead is like holding a 4.5 billion-year-old library in your eyes, a floating archive of our solar system's first chapter. Chapter 29. Asteroids sometimes fall as meteorites. Once they survive the atmosphere, they hit Earth, carrying stories of space chemistry, collisions, and formation. Each meteorite is a fragment of distant history, connecting humans to processes far beyond our planet. They are tangible evidence that Earth isn't isolated. It's part of a cosmic narrative still unfolding. Chapter 30. Comets' tails can stretch millions of kilometers. Solar wind and radiation pressure sculpt them into shapes impossible on Earth. Observing these tails teaches about plasma physics, magnetic fields, and particle behavior. Even fleeting ephemeral phenomena in space follow rules, blending beauty, chaos, and science in one magnificent streak across the sky. Chapter 31. Some asteroids are metallic cores of destroyed planets. Iron and nickel shine beneath layers of rock, remnants of massive collisions long ago. Studying them reveals what planets looked like before they broke apart. These fragments are time machines, holding secrets about planetary formation and the violent processes that shaped our solar system. Chapter 32. Comets sometimes rotate unpredictably. Uneven heating and gas jets act like thrusters, changing spin and tilt. This chaos affects tail formation and orbit stability. Observing these changes is a live experiment in physics, showing that even ice and dust follow the laws of motion, unpredictably yet precisely, across millions of kilometers. Chapter 33. Asteroids can have irregular shapes. Some look like potatoes, others like ragged rocks. Gravity isn't strong enough to mold them into spheres, unlike planets. Their shapes influence spin, collisions, and surface evolution. Even these small bodies showcase physics in action, turning simple rocks into complex cosmic sculptures. Chapter 34. Cometary impacts may have sparked ancient chemical reactions on Earth. Amino acids found in meteorites suggest that life's building blocks might arrive from space. Every passing comet carries potential stories of biology, chemistry, and chance. In a way, life on Earth may owe its origins to icy wanderers from the distant solar system. Chapter 35. Asteroids travel at incredible speeds, tens of kilometers per second. A collision with Earth is over in minutes, but leaves lasting scars. High-speed impacts shape craters, mountains, and sometimes extinction events. Each passing rock is a reminder that motion in space is relentless and unforgiving. Chapter 36. Comet tails are made of dust and ionized gas. The dust creates a curved tail, while ions form straight, glowing streaks. This dual structure is a visual signature of physics and chemistry interacting in space. Watching a comet is like seeing science perform a cosmic ballet above Earth. Chapter 37. Some asteroids have unusual orbits, crossing paths with multiple planets. Their journeys can last millions of years before collisions or ejections. These wanderers demonstrate gravitational complexity and the dynamic nature of the solar system. Even a small rock follows cosmic rules, tracing unpredictable paths with precision. Chapter 38. Comets can fragment when passing near massive planets. Tidal forces tear them into pieces, creating spectacular displays or multiple meteor showers. This destruction is also creation, recycling material and producing fleeting cosmic fireworks. Even endings in space leave lasting impressions on Earth and observers. Memories. Chapter 39. Asteroid families share a common origin. Collisions create clusters of rocks with similar orbits. Scientists trace these families to study past impacts and the evolution of the asteroid belt. Space isn't random. Even destruction follows patterns, leaving behind evidence for those who know. Where to look. Chapter 40. Comets contain trapped gases from the early solar system. When released near the sun, these gases form glowing clouds and tails. They are natural laboratories, showing reactions under conditions impossible on Earth. Each comet is a traveling chemistry experiment, illuminating both science and imagination as it streaks across the sky. Chapter 41. Some asteroids are carbon-rich, containing organic compounds. These rocks act as cosmic laboratories, preserving molecules that predate life on Earth. Studying them helps scientists understand the ingredients for life and how they traveled across space. Each carbon asteroid is a frozen archive, hinting at the chemical potential hidden in the cosmos. Chapter 42. Comets release jets of gas and dust, sometimes spinning them like pinwheels. These jets change trajectory and rotation, making each comet unpredictable. Observing these movements provides insight into physics, sublimation, and celestial mechanics. Even icy what? Chapter 43. Asteroids can collide with moons. Small impacts create craters and eject debris, forming temporary mini-moons or meteor showers. Studying these events helps scientists understand planetary history, crater formation, and the delicate balance of gravity. Even minor collisions reveal massive stories written across celestial surfaces. Chapter 44. Comet orbits can be altered by nearby stars or planets. Gravity tugs at them, sending some into the inner solar system for the first time in millions of years. This cosmic nudge can transform distant wanderers into spectacular celestial events, showing the interconnectedness of space and the fragility of long-term orbits. Chapter 45. Asteroids sometimes split into smaller rocks spontaneously. Thermal stress, rotation, or collisions can fragment them into swarms of debris. These tiny rocks continue orbiting, feeding meteor showers or adding to asteroid belt chaos. Even in destruction, asteroids contribute to cosmic recycling and the ongoing story of matter in motion. Chapter 46. Comets can survive multiple trips around the sun. Each perihelion burns ice and dust, slowly reducing mass. Ancient comets may vanish entirely after centuries, leaving only traces in meteor streams. They are ephemeral messengers, showing the impermanence of celestial objects while delivering knowledge about solar system evolution. Chapter 47. Asteroids sometimes carry precious metals. Iron, nickel, platinum, and rare elements are concentrated in these space rocks. Mining them could fuel future space exploration, but they also reveal solar system chemistry billions of years old. Every metallic asteroid is both a treasure and a science lesson waiting to be unlocked. Chapter 48. Comets have different shapes, some elongated, others nearly spherical. Irregular shapes affect rotation, tail formation, and sublimation patterns. Studying these forms helps scientists predict behavior, potential impacts, and evolution. Even frozen ice balls show diversity, demonstrating that cosmic objects are far from uniform. Chapter 49. Some asteroids have very fast orbits, completing loops around the Sun in under 2 years. These speedy travelers can approach Earth quickly, requiring constant observation. Tracking them teaches orbital mechanics and the dynamic nature of the inner solar system. Speed doesn't equal danger, but it keeps scientists vigilant. Chapter 50. Comets are carriers of dust older than Earth. Each grain records conditions billions of years ago. By studying cometary dust, scientists learn about solar system formation, chemical evolution, and potential origins of life. A comet streaking across the sky is a messenger from the distant past, connecting us to the earliest chapters of cosmic history. Chapter 51. Asteroids sometimes tumble through space unpredictably. Their irregular shapes and rotation make trajectories hard to model. Observing tumbling rocks reveals physics in action: angular momentum, torque, and gravitational interactions. Even a simple rock becomes a classroom for space mechanics, showing that motion is never truly random, just complex. Chapter 52. Comets. Icy nuclei hide layers of dust and rock. When heated near the Sun, sublimation releases gas and forms the coma. Each eruption reshapes the comet's surface, creating grooves and pits. Watching this process is like witnessing geological activity in zero gravity, blending chemistry, physics, and beauty across millions of kilometers. Chapter 53. Asteroids can collide with Earth at angles that create unusual craters. Oblique impacts form elongated their parent bodies, offering clues about planetary formation. Each fragment is a historical record, silently narrating events from before life existed on Earth. Chapter 56. Comets may contain noble gases trapped since formation. These gases provide insight into early solar system conditions, temperature, and pressure. Scientists study them to reconstruct planetary history. Each passing comet acts as a frozen lab, delivering data from billions of years ago, drifting silently through the solar system. Chapter 57. Asteroid impacts can trigger volcanic eruptions and earthquakes. The energy released transfers through Earth's crust, reshaping landscapes and climates. Studying ancient craters alongside geology reveals the combined power of space and planetary processes. Every impact leaves a dot, signature of destruction, yet also a record of Earth's resilience. Chapter 58. Comet orbits can change unpredictably after passing planets. Gravity tugs, altering trajectory, sometimes sending them into new regions of the solar system. Tracking these shifts allows scientists to forecast future appearances and potential Earth encounters. Even icy wanderers follow rules laced with chaos, reminding us how dynamic space truly is. Chapter 59. Some asteroids are dark as coal, absorbing most sunlight. This affects temperature, rotation, and orbital behavior. Scientists study surface reflectivity to infer composition and structure. Darkness in space is more than aesthetic. It shapes destiny. Each shadowy rock carries lessons about energy, heat, and cosmic survival. Chapter 60. Comets release fine dust that drifts into space, eventually joining meteor streams. Each shower is a reminder of past comet activity and orbital history. Observers on Earth witness fragments millions of years old burning in the atmosphere. Meteor showers connect humans to events far beyond our planet, a fleeting bridge between Earth and space. Chapter 61. Some asteroids rotate so fast they could fly apart. Centrifugal forces stress the rock, creating cracks or ejecting debris. Studying spin rates reveals internal structure. Chapter 62. Comets often release organic molecules, including amino acids. These compounds could have contributed to life's origins on Earth. Every comet passing the Sun carries a chemical message from the early solar system. Observing their trails is like reading a recipe written billions of years ago, bridging chemistry, biology, and cosmic history. Chapter 63. Asteroids can have irregular gravitational fields. Uneven mass distribution affects how rocks, dust, and other celestial substances and potential spacecraft interact with them. Studying these quirks improves understanding of orbiting, landing, and mining possibilities. Even small rocks show complex physics, proving the universe doesn't favor simplicity. Chapter 64. Comets sometimes fragment into pieces visible from Earth. Multiple fragments create simultaneous tails or showers. Observing this teaches about tidal forces, rotation, and sublimation. Even destruction in space produces awe, showing that endings can be dramatic, beautiful, and informative all at once. Chapter 65. Asteroids in the main belt vary in size from meters to hundreds of kilometers. Collisions over billions of years created diversity. From rubble piles to solid metal cores, each rock preserves clues about solar system evolution. Observing them is like reading chapters of a history book written in stone. Chapter 66. Comet tails interact with solar magnetic fields. Charged particles follow lines, producing glowing ion tails that can twist and shimmer. These tails are natural experiments in plasma. Physics. Observing them shows the universe's invisible forces at work, painting ephemeral patterns visible for brief, breathtaking moments. Chapter 67. Near-Earth asteroids sometimes get nudged by Jupiter's gravity. This cosmic push can redirect trajectories toward or away from Earth. Planetary interactions are subtle yet crucial in predicting future collisions. Every asteroid's path tells a story of gravitational choreography and cosmic cause and effect. Chapter 68. Comets can survive hundreds of orbits around the Sun before disintegrating. Each passage erodes ice and dust, shaping the nucleus and tail. Ancient comets leave traces in meteor streams, preserving memory of their journeys. These icy travelers are ephemeral yet persistent, silently documenting the solar system's history. Chapter 69. Some asteroids are remnants of failed planetesimals. They never coalesced into full planets, left as rocky witnesses of formation processes. Studying them reveals what early solar system dynamics allowed or prevented. These silent rocks are time capsules, reminding us that not all potential planets survived. Chapter 70. Comets are often unpredictable. Outgassing can change spin, orbit, or trajectory in minutes. Scientists must constantly update models to anticipate appearances. Each comet is a live experiment in physics, chemistry, and chaos, drifting through the solar system while rewriting expectations. Chapter 71. Asteroids sometimes contain ice beneath rocky surfaces. Hidden water may exist in small pockets, preserved for billions of years. Studying these pockets helps scientists understand water distribution in the solar system. Even a tiny asteroid can hold clues to Earth's oceans and the potential for life elsewhere. Chapter 72. Comets emit bright jets of gas and dust that can shift their rotation. Observing these jets reveals how uneven heating shapes behavior. Each eruption is a live demonstration of sublimation physics, turning simple ice into spectacular patterns visible across millions of kilometers. Chapter 73. Some asteroids orbit in groups called families, formed from ancient collisions. Shared orbits and composition allow scientists to trace origins and impact histories. These families are cosmic genealogies, showing that even destruction creates order and predictable patterns over time. Chapter 74. Comet nuclei are often irregular, shaped by collisions and outgassing. This irregularity affects rotation, tail formation, and orbital changes. Even seemingly simple ice chunks follow complex physics, proving that celestial objects are dynamic, unique, and full of surprises. Chapter 75. Asteroid impacts can eject debris into space, some eventually reaching Earth. These secondary impacts provide evidence for past collisions and shape meteorite distribution. Each fragment tells. Chapter 76. Comets sometimes brighten unexpectedly, called outbursts. Sudden exposure of volatile material causes explosive gas and dust release. These events are unpredictable, giving scientists a chance to observe rapid changes in nucleus composition and structure, turning celestial observation into a front-row experiment. Chapter 77. Asteroids are remnants of the early solar system, over 4.5 billion years old. Each carries chemical and structural records from the time planets were forming. By studying them, we glimpse the solar system's infancy, reading a story older than Earth itself. Chapter 78. Cometary dust forms long tails visible from Earth. This dust traces the path of ancient comets and creates meteor showers. Observers witness fragments that survived millions of years, connecting humanity to events far beyond our planet. Chapter 79. Some asteroids are dark and rich in carbon. Their low reflectivity hides their presence until close encounters. Studying these asteroids provides clues about primordial chemistry and potential building blocks of life. Darkness in space carries secrets waiting to be uncovered. Chapter 80. Comets' orbits are influenced by gravity from planets and other bodies. Tiny shifts can send them into the inner solar system or fling them outward. Predicting these movements requires precise observation and calculation, showing the delicate balance of forces shaping every cosmic traveler. Chapter 81. Asteroids can spin so fast that material flies off the surface, forming tiny dust clouds. Studying this helps scientists understand cohesion, gravity, and surface properties. Even small rocks become laboratories for physics, showing how motion and mass interact in microgravity. Chapter 82. Comets sometimes carry noble gases trapped from the early solar system. Analyzing these gases helps reconstruct temperature, pressure, and chemical composition billions of years ago. Each comet is a frozen archive, drifting silently, delivering secrets of our cosmic neighborhood. Chapter 83. Some asteroids are remnants of larger, destroyed bodies. Studying them reveals information about collisions, core composition, and early solar system dynamics. Every fragment is a survivor of ancient cataclysms, silently narrating the story of planetary evolution. Chapter 84. Comet tails can stretch millions of kilometers, shaped by solar wind and radiation pressure. Dust curves gracefully while ions glow straight. These spectacular displays are natural physics experiments, showing the influence of forces invisible to the naked eye. Chapter 85. Asteroid impacts can alter Earth's climate. Dust and aerosols block sunlight, cooling the planet temporarily. Studying ancient craters and extinction events shows how single impacts reshaped ecosystems and life's trajectory. A small rock can change the fate of entire species. Chapter 86. Comets are sources of water and organic molecules. Some may have seeded early Earth, contributing to oceans and life's building blocks. Each passing comet is a courier from the early solar system, carrying ingredients older than life itself. Chapter 87. Asteroids can have unusual shapes, like elongated or flattened rocks. Gravity, collisions, and rotation create these forms. Observing them helps scientists understand internal structure, strength, and evolution. Even irregular shapes tell the story of cosmic history. Chapter 88. Comets sometimes break apart due to thermal stress or tidal forces. Fragmentation creates multiple tails or meteor streams visible from Earth. Destruction in space produces beauty and insight, showing that even endings can have dramatic impact. Chapter 89. Some asteroids contain rare metals like platinum and gold. Mining them is a future possibility, but they also preserve chemical records of the early solar system. Each metallic rock is a combination of treasure and science, teaching about formation and evolution. Chapter 90. Comets' orbits can be chaotic, influenced by planets, stars, and other forces. Predicting their path requires careful observation. Each unpredictable journey demonstrates the dynamic and interconnected nature of the solar system, where even ice chunks have stories to tell. Chapter 91. Asteroids sometimes have small moons orbiting them. These tiny companions reveal mass, density, and gravitational interactions. Studying them helps predict asteroid behavior and potential hazards. Even a small moon adds complexity to a rock drifting silently through space. Chapter 92. Comets can suddenly brighten when hidden volatile layers are exposed. These outbursts create spectacular tails and increase visibility. Each eruption is a natural experiment in sublimation and gas dynamics, showing that even icy travelers can surprise observers. Chapter 93. Some asteroids pass closer to Earth than the Moon. Monitoring these near-Earth objects is crucial for safety. Every close encounter is a reminder that life exists on a moving planet, constantly interacting with countless cosmic travelers. Chapter 91. Asteroids sometimes have small moons orbiting them. These tiny companions reveal mass, density, and gravitational interactions. Studying them helps predict asteroid behavior and potential hazards. Even a small moon adds complexity to a rock drifting silently through space. Chapter 92. Comets can suddenly brighten when hidden volatile layers are exposed. These outbursts create spectacular tails at increased visibility. Each eruption is a natural experiment in sublimation and gas dynamics, showing that even icy travelers can surprise observers. Chapter 93. Some asteroids pass closer to Earth than the Moon. Monitoring these near-Earth objects is crucial for safety. Every close encounter is a reminder that life exists on a moving planet, constantly interacting with countless cosmic travelers. Chapter 97. Asteroids are remnants of failed planets, left over from collisions and formation processes. Each rock preserves chemical and structural clues about what early planets looked like. They are time capsules, silently narrating the solar system's violent youth. Chapter 98. Comets release dust and gas that eventually joins meteor streams. Each meteor shower we see originates from these icy travelers. Observing them connects humans to events millions of years old, offering a fleeting link to cosmic history. Chapter 99. Some asteroids are incredibly dark, absorbing most sunlight. This affects temperature, spin, and orbital behavior. Studying them reveals primordial chemistry and the subtle forces acting on small bodies. Darkness in space carries secrets older than birth itself. Chapter 100. Comets' orbits are influenced by planets, stars, and solar radiation. Small changes can send them into inner solar system or eject them into deep space. Predicting their paths demonstrates the interconnected, dynamic, and unpredictable nature of our solar system, where even frozen wanderers tell stories of billions of years. Thanks for watching Night Drift Stories. If you enjoyed this cosmic journey, don't forget to like, subscribe, and explore more stories with us. The universe is full of secrets, and we've only just scratched the surface. Until next time, keep looking up.